You've been told fire burns because oxygen reacts with fuel. That answer sounds complete, it sounds final. But if you press just one layer deeper, if you ask not what fire does but why it stops, the entire explanation collapses into something far stranger. What we call burning is not a thing that happens, it's a thing that fails to happen until reality runs out of alternatives. And that failure, that limit, is the only reason fire exists at all. This is not philosophy, this is physics. And once you see it, you will never look at a flame the same way again. Here's the setup. You light a candle. The wax vaporizes. The vapor meets oxygen. Heat kicks a few molecules hard enough to break their bonds. Those broken pieces grab onto oxygen, release energy, and that energy breaks more bonds. The cycle accelerates. We call it combustion. But here's the question nobody asks. Why does it accelerate at all? Why doesn't the reaction just fizzle out the moment it starts? The answer is not that fire wants to burn. The answer is that chemistry has no other option. And that difference between a thing that happens because it wants to and a thing that happens because nothing else is allowed is the invisible border that separates almost everything you think you understand from what actually governs reality. Pause and predict what happens next. Imagine you could freeze time during combustion and zoom into a single molecule of methane colliding with oxygen. What decides whether they react or just bounce off each other? Is it chance? Is it temperature? Is it some hidden force? Think about it for a moment. The answer is energy, but not the way you expect. Every chemical bond is a trap. Atoms sit in that trap because climbing out costs energy. If you don't have enough energy to climb, you stay trapped. But if you do, if random thermal motion kicks you hard enough, you can break free. And here's the key. Once you're free, if grabbing onto a different atom releases more energy than it costs to escape, you don't have a choice. You fall into the new trap. The universe doesn't ask permission. It just follows the only path that lowers the total energy. That's not burning. That's inevitability. Now scale that up. One molecule breaks free and grabs oxygen. The energy it releases heats the molecules nearby. Those molecules get kicked harder. More bonds break. More oxygen gets grabbed. The energy released grows faster than it spreads away. And suddenly you have a flame. But notice what's actually happening. The flame is not a thing. It's a region where molecules have no choice but to keep reacting because the alternatives cost more energy than the system has. The fire doesn't burn because it can. It burns because staying unburned is no longer an option. This is the first limit. Chemistry is not a story of what wants to happen. It's a map of what cannot not happen. And every reaction, every bond, every release of light and heat is just the universe taking the only road left when all the exits are blocked. But here's where it gets strange. If fire is inevitable once it starts, why does it ever stop? You've seen this. A candle burns for hours, then goes out. A forest fire rages, then dies. If the reaction is so inevitable, what shuts it down? The obvious answer is you run out of fuel or oxygen, and that's true. But it's not the deep answer. The deep answer is that fire is a balance, and balances are fragile. Every flame sits on a knife edge between two limits. On one side, not enough energy to keep breaking bonds. On the other side, not enough material to react. The flame doesn't stop because it's done. It stops because one of those limits gets hit first. And here's the thing most people miss. Even when fuel and oxygen are still present, the flame can die. Because heat has to stay concentrated. If it spreads too thin, if the environment pulls energy away faster than the reaction can generate it, the system drops below the threshold and the whole thing collapses. This is the second limit. Fire doesn't burn until it's finished. It burns until it can't anymore. And the moment it can't, it vanishes as if it was never there. Now let's test your intuition. Misconception number 1. Fire is a physical substance, something you can point to and say that's fire. But fire is not a substance, it's a process. You can't bottle a flame any more than you can bottle a wave. What you see glowing is not the fire itself. It's gas molecules vibrating so violently from released energy that they emit light. The flame is the side effect. The real event is invisible. Bonds breaking, energy flowing, limits being tested and breached. Misconception number 2. Combustion needs a spark to start because otherwise molecules are stable. But molecules are never stable. Stable is a word we use when change happens too slowly to notice. Every molecule is vibrating. Every bond is flexing. At any given moment, a tiny fraction of molecules have enough energy to react. They just don't. Because without a spark, the energy they release spreads away faster than it can trigger more reactions. The spark doesn't create the reaction. It tips the balance so the reaction can sustain itself. It's not ignition, it's permission. Misconception number 3. Oxygen is fuel. Oxygen is not fuel. Oxygen is the trap the fuel falls into. The fuel, whether it's wood or gasoline or methane, stores the energy. Oxygen just provides a lower energy state for the carbon and hydrogen to collapse into. The energy was always in the fuel. Oxygen is just the excuse the universe needed to let it out. Here's a reality check. You flip a light switch and a bulb turns on instantly. It feels like electricity races through the wire at light speed. But the actual electrons are drifting at about a millimeter per second, slower than a snail. What moves fast is not the particles, it's the permission to move. The electric field propagates at nearly light speed, and that field shoves every electron in the wire at the same time. The signal is instant. The substance is not. Fire works the same way. The reaction front, the edge of the flame, moves fast. But the individual molecules are not racing anywhere. They're just sitting there, waiting for enough energy to arrive so they can do the only thing left available. Now we go deeper. Feynman had a way of thinking about questions like this. He didn't ask what fire is. He asked what would have to be different for fire not to exist. And when you flip the question like that, something startling appears. Fire exists because atoms are lazy. Not lazy in the sense of unmotivated. Lazy in the sense that they always take the path that costs the least energy. If there were no lower energy states to fall into, combustion would be impossible. If entropy didn't demand that energy spread and disperse, flames would never go out. Fire is not a phenomenon. It's a gap between two limits, and we happen to live in the narrow band where that gap is wide enough to notice, pause, and predict what happens next. Imagine you're in a pure oxygen environment. No nitrogen, no carbon dioxide, just oxygen. You light a match. Does it burn brighter, faster, or does something else happen? Think it through. The answer is, it burns violently, explosively, because nitrogen in normal air acts as a buffer. It absorbs energy without reacting. It dilutes the oxygen, so the flame has to work harder to find molecules to react with. Strip that away, and the reaction rates skyrocket. Flames that would take minutes to spread now spread in seconds. Metals that don't normally burn in air, like steel, ignite. The limit that normally constrains the reaction, the availability of oxygen, vanishes. And when a limit vanishes, the system doesn't just speed up. It changes character entirely. This is why oxygen-rich environments are catastrophically dangerous. It's not that fire likes oxygen, it's that the barriers that normally hold fire in check are gone. Misconception number 4. Heat makes things burn. Heat does not make things burn. Heat makes molecules move faster, which increases the chance they'll have enough energy to break bonds. But the breaking is not caused by heat. It's caused by probability. At any temperature above absolute zero, some fraction of molecules will have more energy than average. Heat just shifts the curve so more molecules end up in that high-energy tail. The fire doesn't start because it's hot. It starts because enough molecules finally won the lottery. Misconception number 5. Fire needs continuous fuel input to keep going. Not always. In a zero-gravity environment, flames behave completely differently. On Earth, hot gas rises, pulling fresh oxygen in from below. That convection sustains the flame. In space, there's no up. Hot gas just sits there. The flame becomes a sphere, slowly consuming oxygen from all directions until it chokes itself out. Same fuel, same oxygen, different limit. The flame dies not because it ran out of materials, but because it ran out of access. Here's another reality check. Inside a car engine, gasoline vapor mixes with air and gets compressed. The compression heats it up, then a spark ignites it. But here's what's strange. The spark doesn't ignite all the fuel at once. It starts a flame front that propagates outward at a specific speed. If the fuel ignites too fast, you get knocking. The pressure wave bounces around and damages the engine. If it ignites too slow, you lose power. Engineers spend entire careers tuning that balance, not because fire is unpredictable, but because fire obeys limits so precisely that even a tiny shift in pressure, temperature, or fuel mixture changes everything. The flame is not wild, it's relentlessly lawful, and that's what makes it so hard to control. Now here's the part that breaks most people's models. You've been thinking of fire as a thing that happens when conditions are right. But flip it. Fire is what happens when nothing else is possible. Every molecule in the unburned fuel is sitting in a higher energy state. Every molecule wants to fall, not once in the emotional, once in the thermodynamic sense. The system is unstable. It's a ball balanced on a hill. The question is not, why does it fall? The question is, what took so long? This is the third limit. Reality is not neutral. It has preferences. It prefers lower energy. It prefers higher entropy. It prefers spreading and mixing and breaking symmetry. And when you light a match, you're not forcing the system to burn. You're removing the last barrier that was holding it back. Misconception number 6. Explosions are just very fast fires. Explosions are not fires. Fires are reactions limited by how fast fresh oxygen can arrive. Explosions are reactions where the fuel and oxidizer are already mixed, so the reaction propagates faster than sound. The limit is not diffusion, it's chemistry itself. And when chemistry is the bottleneck, the reaction becomes a shockwave. Same bonds breaking, same energy releasing, different limit, completely different outcome. Here's a third reality check. The sun does not burn. People say the sun is burning, but combustion requires oxygen. The sun fuses hydrogen into helium under pressures and temperatures so extreme that nuclei overcome their electrical repulsion and merge. The energy released is not from bonds breaking, it's from mass converting directly into energy. But here's the parallel: fusion, like combustion, only happens because the system has no other choice. At 15 million degrees, hydrogen nuclei are moving so fast that when they collide, quantum mechanics allows them to tunnel through the electrical barrier that should keep them apart. It's not that they want to fuse, it's that the universe ran out of ways to stop them. Same principle, different scale. The sun is not burning, it's falling into the only state left available under those conditions. Now we return to the candle. You're watching the flame flicker. You know now that the flame is not a thing but a region. You know the molecules are not choosing to react but falling into the only path left. You know the fire will stop, not when it's done, but when it hits a limit. But here's the final question. Why does any of this matter? Because almost everything you think is solid and permanent is actually balanced on a limit. The chair you're sitting on is not solid. It's electrons repelling other electrons with such force that matter cannot pass through. The atoms are mostly empty space. The solidity is an illusion created by a limit. The limit of how close electrons can be pushed together before quantum mechanics says no. The air you breathe is not still. It's molecules smashing into each other billions of times per second. The stillness is an illusion created by a limit. The limit of how much energy is available to organize that chaos into visible motion. The warmth you feel is not heat flowing into you. It's your molecules borrowing energy from nearby molecules faster than they lend it back. The warmth is an illusion created by a limit. The limit of how fast energy can equalize across a boundary. Fire is not special because it burns. Fire is special because it makes the limits visible. For a few moments, you can see energy cascading from a higher state to a lower one. You can see molecules trapped by one limit and freed by another. You can see the universe doing the only thing it knows how to do, Follow the path of least resistance until there's no resistance left. And when the flame finally dies, it's not because the story is over. It's because reality hit a wall it couldn't cross. And on the other side of that wall, in the cold and the dark, the limits are still there, still governing, still deciding what happens next. The fire never burned because it wanted to. It burned because nothing else was possible.